Here students, problem number 1. This is based on the new method, and as per the theory, your very last value of the actual demand for the latest time period is your actual forecast for the next time period. Yeah. So here is the data given. Let's quickly read through and understand what the data is. So the problem says a commercial bakery has recorded sales in dozens for 3 products as shown below. So again, if I quickly understand the structure of this table, the very first column is day and looks like day 1 to 15 is the data given. Then the next product that is sold in dozens is blueberry muffin. Next one is cinnamon buns. Next one is cupcakes. And here is a rough data given 40, 41, 43. So it looks like everything is in 40s. There is 139s. Cinnamon buns in dozen 18, 17, 19, 20. So it looks like it starts with 18-ish and steadily increase until 34. And for the cupcakes, looks like the first number is 58, 24, 30, 60, 36, 29, 28, 57. So it looks like there are some highs and there are some, or most of the data is in 20s and 30s, and there are some big spikes like 58, 61, 57, 62. Yeah, so this is, we quickly glanced through the data and understood, because that's the first thing to do is understand your data. Now let's read the question. The question says predict orders for the following day for each of the products using new method, trend adjusted new method and seasonally adjusted new method. And the last question has parentheses that says if seasonal cycle exists. Yeah. So let's start solving this problem. And just for your convenience, I have copy pasted all these values into an Excel sheet, which I provided to you in our Canvas section. So this is the data given. So yeah, day, the first product in dozen, that is blueberry muffins. Always a good practice to have units and write units. So dozens and cupcakes. So the very first question, say let's call it as A. Using new method, make a prediction of what they are saying. So as per the theory, the last number of sold quantities is here, forecast for week number 16. So I'll add this week number 16 over here. And as per this new method, I'll just say equals to 42, or select the cell D16, and I'll just expand the formula horizontally. So my first question is answered using new method. Yeah. Second one, so this is a step ahead of the basic new method, that's called seasonally, yeah, trend adjusted new method. In this you do like very similar thing, but there is one different things you do. Yeah. So again, it's a two-step process. The very first is you identify the difference between the most recent time period, which is 15, and the previous one, which is 14. Yeah. So you subtract this actual demand or actual sale value in week 15 minus week 14. Yeah. So this is what I'm doing. So equals to 42 minus this 43, enter. So it's -1. So that's a difference. I'll expand it horizontally. So now, as per this trend adjusted new method, I am supposed to add the latest actual sale value, which is this 42, with the difference over here. Yeah, so that's what I'm doing. So I'm going to say equals to the sale for week number 15 for blueberry muffin, which is 42, plus the difference between week 15 and week 14. So this is the one. So this is my answer. So that's my trend adjusted new method for blueberry muffin in dozen. And I'll just expand this formula sideways. So it yeah, so by doing that, I got the same trend adjusted new method forecast for cinnamon buns as well as cupcakes. These are the values. So these are your answers. Third one says seasonally adjusted new method if a seasonal cycle exists. So again, just glancing at this data, I have no idea whether it's trending up, trending down, or there is any seasonal wariness within the actual data collected. So for that, this is a very important thing. I think it's one of a key takeaway. So all I'm going to do is I'm going to select all these cells right from C2 until F16. So I'm selecting this in my Excel. Then I'm going to go over here, say insert in Excel, then I'm going to go over here for the line chart. So you see in this charts option, there is this line chart. And again, you can pick any, but yeah, this time I'm going to pick this line with markers. Oops, I see one issue. So even this x-axis, d that was supposed to be an x-axis, it has been plotted as a y. So that's the error. So let's go ahead and correct that. So I'm going to right click in the area over here, say select data. First, I'm going to identify which one that is. Very likely this is the one, but let's check. I'm going to select series 1, edit. I'm just going to check the data. Oh, awesome. Yeah, so this is the one that is just series 1. I'm going to say OK. I'm just going to remove it. So by that, yeah, the trending upward line has been removed. I'm going to go over here in the X, edit, and I'm going to select these. Well, technically it's the same, but here I'm just using the actual data. Here, Excel just came up with the best it can. So by doing that, yeah, I got it. Yeah, this chart over here. And another very good practice, although it's not a part of this problem, very good standard practice I will have you guys like get habituated is let's get at least the title of the chart over here. So this I'm seeing product. Oh, sorry. I will say products say sold, PRODUCTS, sold versus days. Yeah. So that's the heading of this chart we are seeing. Yeah. And this is series. Well, you can name it. One way is select the data. Here it says series 2. That's why you are seeing series 2 and respectively series 3 and 4 over here. So I can select this. I can go to edit. And in the series name, I know the first one is blueberry muffin. So all I'm going to do is select blueberry muffin and dozens. Yeah, you see as soon as I did it, this is what you are seeing. Again, not necessary for this problem, but again, as a standard practice if you want. So I won't do for the rest ones. Yeah. So coming back to the main problem, our goal is to see if there is any if seasonal cycle in any of this product or the demand or actual sale data collected. So looking at the very first, which is my series 3, the very first say blueberry muffin with the red one I'm seeing. If I quickly look over here, more or less it's, I can see couple peaks over here. So one, so again 1 2 3 4 5 peak, 1 2 3, well, not really 1 2 3. So I'll just clearly state that I don't see any seasonally adjusted trend or seasonal cycle in this first one. Second one, series 3, which is your cinnamon buns. Again, I more or less it's linear curve. I say the demand is more stable and it's increasing at a more or less a constant rate. The third one, cupcakes. Well, I can see one point over here, which is your 58 actual sale. Then there are a couple down, and then again there is a spike over here. Then there are 3 points down. Then there is a spike over here, 50s, and again here also there are 3 downs and 1 spike, and then 3 downs. So quickly glancing through, looks like yeah, we are seeing a consistent pattern over here. So these numbers, the peaks are around 58s to 60s. I'll say on an average 60, and these numbers are around 20s and 30s. So I can clearly make an inference that looking at this trend, definitely I see a seasonally adjusted cycle. So the question, seasonally adjusted name method, if seasonal cycle exists, I will infer that looking at this data trend, there is a seasonal cycle. And well, yeah, peak 1 2 3, peak 1 2 3. And since I know I'm using a name method, I will just pick for my 16th week the very last peak value, which is 62. Yeah, so by that logic, I will say here for the cupcakes, it will be the demand will be, or forecast will be 62. This is, I'll say none, and so on. But yeah, again, let me center this, let me highlight it with yellow because yeah, that's what we are doing for the answer. So technically, this is how we solve our first problem using name method. Now let's go to the second problem. Again, it's a combination of name method and moving average. So let's read the problem and understand what the data is. So National Scan Inc. sells radio frequency inventory tags. Monthly sales for 7 months period was were as follow. So it looks like from February. Yeah, so it looks like from February until August, this is the actual sales of radio frequency inventory tags in thousand, in thousands, so 18,000, 21,000, and so on. So let's read the question. So I think yes, straightforward data. So forecast for September sales volume using each of the following. The first one is name approach. A second one is 5-month moving average. Third one is weighted average using zero point 0.6 for August, very close is 0.6, 0.1 for July, and 0.3 for June. Again, these are given conditions, so we have to follow. And fourth question is a trend, a linear trend equation. Yeah, so again, forecast for September using linear trend equation. So awesome, this will be a fun assignment to solve. And for your convenience, I have again copy pasted all these numbers into an Excel sheet and we'll be using Excel. And again, it's not mandatory, you can use a calculators also if it is simple enough for you. But again, as a long-term standard practice, getting familiarized with Excel, at least a basic hands-on is very important. So yeah, try to follow your Excel. So with that said, I'm going to this second sheet that says PR2 and this is the data given. So the very first, and just for your convenience, I added these things also. So first question, new method approach is make a forecast for September. So as per the new method approach, well, immediate previous value is my next month's or next time periods forecast. So this answer will be 23 straightforward. Question 2 is 5-month moving average. So this is fun. So again, like yeah, total there are 7 months of data given over here, count 7. And when I say 5-month moving average, I'm supposed to get the average for most recent 5 months. So these are the ones. So let's do that. Yeah. So again, I'm going to say equals to AVERAGE and 1, 2, 3, 4, 5. Yeah, from August to April. And close the bracket, enter. So yeah, by that logic, my September's forecast using 5-month moving average is 21.4. And on top of it, if I just I add my own creativity beyond this what's given. If I want to calculate a 3-month moving average, this is what I will say. So equals to AVERAGE of August, July, June. Close, enter. Yeah, so as per 3-month moving average, it's 23. Yeah, then fourth one, weighted, third one, it says calculate the weighted average using 0.6, 0.1 and 0.3 for August, July and June respectively. So let's do that. Yeah, so again, this will also be Control C for September and say equals to, and let me start with the bracket and I will say first one 0.6. So I'll say 0.6 multiplied by August, yeah, plus 0.1 multiplied by the sale in July plus 0.3 multiplied by the sale in June and close it out, enter. So yeah, by that logic, my September forecast using this weighted average and these are the weights. This is my forecast for September. Yeah, so that's my third. Fourth one is exponential smoothing with a smoothing constant of 0.15. Yeah, well, let's hold off to this one. I think for the scope, again, I took this problem from a statistics book, which was a part of this as well. And I think for the scope of this class, this is too advanced. So yeah, let's hold off to that because yeah, we have to do some extra calculations, and I don't think at this point it's necessary for you because this is me bringing in this calculations part for you. So let's jump to the fifth problem, which is a linear trend equation. I think this is much more beneficial for you. So on that note, yeah, let's use Excel. So I'm going to select all the cells from C2 until D8. Go to insert. Again, the same thing. Within chart option, go to lines, 2D line, and I'm going to select this line with marker and chart it out. And immediately I should know what I'm looking at. Or again, if I'm presenting this to my boss, or if you are presenting this chart or analysis to your boss, standard practice is have at least a title. So this is what sales versus month. Yeah, and again it says, well, I can give I think it was radio frequency tags, right? I'll say tag sales versus MO and TH. Yeah, let's use simple, and again I can say in thousands, right? 1000 s space out. I think this is good enough as a scope of this class. And then linear trend. So they are asking me to fit a linear line. Again, if this function in Excel wasn't available, and again several years ago, very recently, this wasn't available. So again, if this question was asked to you, you really had to do a lot of statistical calculations and do that line curve fitting. But thanks to Excel, it has made everybody's life easy. So for that, I'm going to click on this line over here somewhere, left click, right click on the line while this whole line is selected, and I'm going to say add. You see this window pops up. I'm going to say add a trend line. And as soon as I do that, you can see a line is added. So all the statistical functions are embedded and programmed within here, Microsoft Excel, and it will do the curve fitting, line fitting, and this is the line. It will give you a best fit line. At the same time, a window like this will pop up. It says format trend line, and by default it will take linear, and that's our question, linear, and there are multiple options. But again, this you can learn in some of the statistical classes. But yeah, our first thing is completed. We fitted a linear line over here. Now let's add an equation to it. And for that reason, if you go down, you can see display equation or chart. Yeah, it's unchecked. I'm going to check it. Also, there is this thing called as display R squared value on chart. I'm going to select it. And yeah, you see these couple of things got added. I'm going to move this over here. And maybe I'll just make this bigger so that it's easily visible. Awesome. Yeah, 14 is good. So on the first row, I can see an equation, and second row, I can see an R square value. So again, a linear trend equation is given here, and that's so we have to use this and make a prediction for September. Yeah. So again, linear trend EQ, and I'm again going to say a forecast for September. Little bit yellow, same thing. So now, so Y value, which is my forecast for the month of September, equals to, and here X is my number of month used. So currently we have 1, 2, 3, 4, 5, 6, 7. So September will be my 8. Yeah, it's in a sequential format. What is the count? So this is my X. And yeah, I think I have other variables. Yeah, so let's do that. So I'm going to say this is my equation I'm going to use. So equals to, yeah, I am a fan of brackets, so I'll just start with a bracket. You don't have to, but 1.0714 multiplied by 8. And that again, I'll repeat, 8 is the month September. And because the data given here is 7 month, right? February is 1, 2, 3, 4, 5, 6, 7, and 8. So that's my 8. And plus 16.571. Close it out, enter. So as per my linear trend, this will be my forecast for the month of September. And again, I'll just do some standard units. Yeah, let's everywhere use second. Yeah, 2 digits. I think 2. Yeah, maybe in this case 1 digit is. Oh, sorry, 1 digit is good. So 25.1 will be my forecast. And the next thing, as we have discussed, and this is an extra information unnecessary over here because it is not saying make a comment about your confidence and R square and so on. But again, R square here is 0.4. And if you look, definitely there is a high variation. So this is my best fit curve line. And again, there are some points which are very close to this line, but there are some points which are very far away. That's a high variation away from your standard line. And that's the reason why my R square is extremely, I'll say for me, this is not so good. Like we discussed in our class, R square ranges from 0 to 1. 0 means very low confidence, 1 means highest confidence, and usually anything more than, I say, 0.7 or 0.75 should be treated with good level of good data collected for good level of confidence. So this 0.4 says that maybe I'll have less confidence. But overall, again, that's not the case. So I mean, they haven't asked for it, so we'll stay with it. Yeah. So as per the linear trend, this is my answer. Yeah. So this solves our problem number 2. Next one, problem number 3, numerical problem, and this is using linear trend. So let's quickly read, understand the problem, and understand the data given. So the very first is freight car loadings over 18-week period at a busy port are as follows. So again, I can see there is week number, week 1 to 6, week 7 to 12, and week 13 to 18. And these are the loadings: 360, 375, 390, 375, 390, 400, then 430 all the way to 495, then 505 to 590. Quickly glancing, 18 weeks of data given, as well as the numbers. Well, a quick glance, well, I can confidently say that it's steadily increasing from 360 to 400, 400 to almost 500, 500 to almost 600. So somewhat increasing trend. Now let's read, understand the questions, and then we can solve the problem. So the very first is determine a linear trend line for expected fleet car loading. Yeah, so that's the first thing we are supposed to determine. Second one is use the above trend equation to predict expected loadings in week 20 and 21. Yeah, so again, this is maximum given is 18, then there is week 90, then 20, 21. So to make that prediction using the equation. Then C question says a manager intends to install new equipment when the volume exceeds 940 loadings per week. Assume the current trend continues, in which week at earliest should the loading volume reach the level. So indirectly, what they are saying, or the manager is saying, is in which week number, going with this trend 360 to 400 increasing, 400 to 500, 500 to 600, in which week will it reach the loading level of 940. Yeah, so again, if this trend continued, say like 19 to 24, then 25 to 30 and so on, in which week it will reach the 940. Yeah, so you have to use the equation to predict the week. Yeah, so it's kind of it's a reverse thing that I've given. So for your convenience, again, I have copy pasted all this information into our Excel sheet, and I'm going to go to PR number 3 over here. And yeah, maybe this is too small. Let me make it bigger. And yeah, this is all given. So again, I have copied, I have pasted everything in a vertical manner. So week 1 to 18, these are the numbers, loadings that have been copy pasted. So straightforward, we can start with our first one. Let's say determine a linear trend for expected fleet car loading. So again, I am going to select everything from cell A2 until B90. Go to insert, go to this chart option, line linear, select this. And oops, looks like even this part has been identified as a y value. So let's fix that. Yeah, and yeah, the very first is chart title. Again, best practice. Yeah, always have to have a correct chart title. So this is loadings versus week here. And you can add more details if you want, but yeah, I think for the scope of this class, this should be enough. And again, I will make this a bit bigger. It's too bigger. Then let's fix this. I'm going to right click anywhere over here, select the data, and I know this is series number 1. I'm going to remove it, and I'm going to select add label, and I'm going to select all these weeks from 1 to 18. Go back. Okay. Come back. Awesome. And since only, well, hello, it's fine. Yeah. Then determine a linear trend. Yeah. So again, I'm going to select left click on this line where everything is selected. Then I'm going to right click somewhere on this line and say add a trend line. Again, accelerate this thing and tried its best to fit a line, which we can see over here. And again, there is one thing got added, which is linear series 2. And a window like this again pops up that says format trend line by default is linear. And again, we are looking at linear. So this is good. Again, I'm going to say display the equation on chart. It doesn't say about R square, so I'm not going to select. And yeah, let's continue this way. And yeah, let's make this a bit bigger so you can see on here. So let's make it 14, say. Awesome, this is good. Bold. So this is my linear equation. So this is my, so as per this my linear trend expected fleet of the car loading, this is my linear equation. This is my first answer. Then use the above trend equation to predict value for loading week number 20 and 21. So again, here, this is my equation, y equals to a constant 13.658 times the week number, or the in sequence the time number, yeah, the time lapse number. So in this case, it's in our case, we are supposed to use week 20 and week 21, and everything else we know, right? So let's do that. So I'm going to say equals to fan of brackets. I'm going to start with the bracket 13.658 times 20, that is week number 20, plus 334.41. Close it out, enter. So that's my projection or forecast using linear trend method. And here I'll just copy and paste this value. And the only thing I'll change is instead of week 20, I'm going to say week 21. And by that logic, again, this is my forecast. And here there are no decimals. So I'll, just take away all the decimals. Let's make it presentable. So again, I'm highlighting in yellow because these are my answers. So, and then add a border line. This should be good. So this is our answer to question number B. Use the above trend equation to predict expected loadings for week 20 and 21. Now the next one is a manager intends to install new equipment as soon as the volume exceeds 940. So again, indirectly they are asking in which week number will we get this y of 940. Yeah, so again indirectly we know our 940, and again we are supposed to find week number what. So let's do the control X, control V. So let's do a reverse. Again, if I have to do solve for this X, what I'll be doing is y minus 334, right? So again, oops. Let me just take this off. Control X, control V. So equals to, what I'll do is 9 equals to bracket 940 minus 334.41, 334.41, bracket closed. So X stays here, divided by 13.3, that's 13.658, right? Yeah. So divided by 13.658. Again, there are multiple ways you can do it. For now, I'm just doing it manually. But if you're good at Excel, you can do it. You can do advanced level of Excel. But again, I'm just doing it manually. So with that said, it's telling me on week number 44.33. Let's round it up to the next level. So we say, maybe less than here. So by that logic, it's like almost on week number 44, or even if it is, you can say, if you say 45, I'll be okay with it. And technically, I think it's 45. Yeah. Again, calculation wise, it's this number, but I will be precise. So let's see. 45. So technically on week number 45, they will reach that loading level of 940. So again, I'll say NSWER. So this is how we solved the third problem as well. Now let's go to the fourth problem. Again, we are supposed to use linear trend, and again, let's understand the data, question and the data. So air travel on mountain airlines for the past 18 weeks was this: week 1 to 9, week 10 to 18, and passengers is 400 to 438, 440 to 482. So it looks like more or less there is a steady increase, upward trend. The question is, use an appropriate technique to develop a forecast for expected number of passengers for the next 3 weeks. So again, they are saying use appropriate. So they haven't told us like whether we must use naive method, average method, and or a linear trend method. So let's see how to solve this problem. So for your convenience, I copy pasted everything in Excel. So let's go to Excel sheet PR4. So so they're asking for the next year. So again, I can use a naive method. So as per naive, or the same thing, I can use, say, 3-point moving average. I can use a 5-point moving average. And in the next problem, we will discuss a bit more on which is the appropriate method. But for now, let's just do it. And here I will use, and this is, let's treat this more as a practice. So linear trend for 19, 20 and 21. Oops, what did I do? Perfect. So as per new, just last number, so 482, 482, 482. Yeah. So technically we stay at 482 if we go with naive method. And in this case, clearly it's from 405 it has reached to 482. So maybe this isn't as appropriate. If I go with 3-point moving average for week 19, so it's equals to AVERAGE of the from the given data latest three. So 1, 2, 3, close. For week number 20, the 3-point, assuming 19 is for 2019 is the actual, so equals to AVERAGE of the actual value for week 19, which in this case, which is this. I'm going to select this, then comma 18 and 17, close, enter. And for week 20, the forecast for 20 and 19 are treated as actual, and we do the average. Yeah, so equals to average of week 20 and 19 using 3-point, comma, hold control key on your keypad, and if you're using a Mac, use command key and select this 18, close, enter. Awesome. So using 3-point moving average, these are the numbers you get. Using same thing you do for 5-point moving average. Yeah. So equals to AVERAGE of 19. So hold control key and select 1, 2, 3, 4, 5, 18 to 4, yeah, 14 to 18. That are your 5. Close. Oops. Average. Something is. Yeah, let me fix it. Equals to AVERAGE of 19th, right? So I'm going to select 14 to 18. Close it out. Perfect. Yeah, this is. So why is it telling average of beef? Oh yeah, perfect. Beef. Yeah, perfect. This is correct. Then the next part, which is 5-point moving average for week 20. So in this case, 19 my actual. So equals to AVERAGE of hold control 19, comma 2, 3, 4, 5. Close, close, enter. Perfect. For week 21, these two are my real, and then 3 from here. So again, why these two are real? Because this is week 20, week 19, week 18, 17, and 16. Yeah, so equals to AVERAGE of these two, comma, hold control or command on your Mac. These 3, close, enter. Perfect. Yeah, these are my 5-point moving average values. And then finally, linear trend for the given data. So again, I'm going to select cells A2 until B19. Go to insert, select this, and chart title week PASSENGERS versus week number. Something like that. That's a fair enough title. Let's make this a bit bigger. Again, I know this isn't correct, so I'm going to right click, series, delete here, select x-axis week 1 until week 18, close it back. Okay, so this is corrected. I'm going to select this, right click anywhere, say add a trend line. Again, a trend line has been added, linear is correct, display equation, and this is the equation that is being displayed for the curve. To make it bigger, 14, and this is my equation. Yeah, so again here x is my 19 for this case, and all other I know, so I'm going to solve it for it. So equals to 4.5934 multiplied by x is 19 plus 396.97, 396.97, enter. Yeah, so that's my using this linear trend. I want to copy the and same thing here, paste it over here, and instead of 19, I'm going to change it to 20. And here I'm going to copy the same thing, Control C, Control V, and here instead of 20, I'm going to change it to 21. So yeah, using these one naive method, 3-point moving average, 5-point moving average, linear, these 4 methods, these are the projections we got. So this solves our problem number 4 as well. Let's move to the next problem, which says new car sales. Yeah, so let's read it out for problem number 5. New car sales for a dealer in Cook County, Illinois for the past year are shown in the following table along with monthly indexes, seasonal relatives, which are supplied to the dealer by regional distributor. Yeah, so again, if I quickly glance to this table, there is months, units sold, index, months, units sold, index. Yeah, so for month January to June, and next part, a continuation is July to December. So looks like 12 months of data is given. Units sold are given. So again, 647 to 843 and 763 to 783. So it looks like from here to here there is an increase, and then again there is a step difference, 843, 763, and then looks like there is an increasing trend, but still not matching until 843, and then there is a drop. So it looks like, yeah, it's an irregular data, irregular trend, and on top of it there is something called as index value given. Yeah, so yeah, this is the data given. The two questions that have been asked is, let's de-seasonal the car sale. So this is more of a, yeah, as you can see, the monthly, yeah, seasonal relatives are given. So based on that, we have to de-seasonalize the car sales. And what is your inference based on your findings in the part A? That is the deseasonalized data display a downward trend or the deseasonalized data display an upward trend? Yeah, so that's the prediction you have to make. So yeah, let's go ahead and solve this problem. And for your convenience, again, the data is available in your Excel sheet. Let's go to this. Well, not. Then let's go to PR5. And yeah, I copy pasted this data, January to December sold and indexes. So let's deseasonalize the data. Again, it's a simple division formula. So in order for you to deseasonalize the car sale, all you have to do is divide this unit sold with the index. Yeah, so let's do that. So equals to 647 divided by this index, enter. So as per the deseasonalized unit sold, this is my number, which is 924.3. I'll drag this formula all the way down, and these are the numbers I'm getting. So we completed the first part. We deseasonalized the car sales, and then what is your inference based on your findings per day? Is it showing downward trend or upward trend? Yeah, for that again I'm going to select all these cells from A3 until A14. Hold control because I'm using a Windows computer. Hold control key, and if you are using an Apple Mac, please hold command and select all the cells from D3 until D14. So again, these two columns are again partial columns are selected. I'll go to insert, and in the charts select this and plot it out. And again, as a good practice, let's say deseasonalize. I'll say deseasonalized seasonalized sale versus MONTH. Yeah, something like that. I think this is a good title to start with. And yeah, the question says, what is your inference based on your findings in the part A? So quickly, a quick glance through it, definitely there is a downward trend. And if I want to, yeah, actually verify it, I will just say add a trend line. Again, it's trending down. So this is more, I'll say graphical data, quantitative data, analyzed data. So again, downward trend. And if I add an equation, looks like there is a negative component to it. So definitely it's as time goes by, the sales are yeah, going in a downward direction. So yeah, this statement, the first statement, the deseasonal data displays a downward trend is should be your answer. And again, I used all these variety of problems just to give you a glimpse of of understanding about how these Excel formulas are used, or how these kind of problems can be solved in Excel, and how to use these Excel like basic formulas as well as charting the linear chart, add a trend line, and get the linear like equation. And as you go forward, there are multiple, you can use advanced level of equations as well, but I think that's out of scope for this class. So let's keep it to this point only. So with that, we solved problem number 5 as well. Let's move on to the next part. Very important. Say problem number 7. Yeah, and I think I have skipped problem number 6 because it was, I think, yeah, a continuation of this or this. So let's move to like the next theoretical part, which is problem number 7. So again, as per this problem, it is more mean absolute deviation MAD and mean square error. And if you have taken our statistical class, statistics business stats 1 or business stats 2, we do teach much more detail of these. But for the scope of this class, I think, yeah, just know that MAD is mean absolute deviation and mean square error. In other words, this is also equals to variance. And if you do square root of this, you get your standard deviation. But again, that's out of scope, so do not worry too much. Just remember that the formula for mean absolute deviation is summation of yeah, of these entity, which is a mod value, which is like whether it's a positive or negative, you just consider positive. So you do a difference between actual minus forecast value divided by the number of observations. And for mean square error, which is variance, you get the difference between actual and forecast, square it up, get summation of all, and divided by number of observations minus 1. And yeah, so like few minutes ago, we solved that problem where it said use appropriate method, right? Use appropriate technique to develop a forecast for expected number of passengers for next week. So again, we did it and we got our answers, but how do we know which one is your appropriate method? So here is the answer for it. Oops. So here is your answer. The method that has the least values of mean absolute deviation and MSE is the appropriate method. Yeah, so that's as per the theory. So let's read this problem, solve this problem, and we'll know much more about it afterwards. So the question says an analyst must decide between two different forecasting techniques for weekly sales of roller blades, a linear trend equation and naive method approach. So yeah, he was two different techniques. Okay, awesome. So linear trend equation and a naive method is what he's using. The linear trend equation for is already given. It says that it's forecast, which is y equals to 124 plus 2 times t, which is here x when we saw solved in our Excel. But in this case, he's using the terms ft and t, and it was developed using data from period 1 to 10. Yeah, so again, yeah, this was done based on period 1 to 10, and the data is given from a period 11 to 20. Yeah. So yeah, this is given and data given. So for your convenience, we have copy pasted everything in Excel and also added these parts. And our goal over here is to decide which forecasting technique is the appropriate one. Yeah. So for that, we'll be calculating MAD and MSE for the first, which is linear trend equation, as well as for naive method. And yeah, just plugging those numbers over here, and just whichever numbers are lower for MAD and MSE for each of these method should be the method that is that should be picked. Yeah. So for that reason, let's go to our Excel sheet and solve this problem. Yeah, coming back over here, and just for your visual reference, and like I always say, you know, last time we talked about the visual management, so maybe you can treat this also as a part of visual management. So I just copy pasted the formula so that you know what are you supposed to solve, and again, this is the equation given. So yeah, this is the information given for week number or time period number 11 to 20, and based on time period 1 through 10, this is the equation they have derived. So let's go ahead and solve the problem. Yeah, again, I mentioned this over here. Maybe let me make it a bit bigger. I think this should be good. So the very first, yeah, let's calculate, yeah, using linear equation, which is forecast equals to 124 plus 2t. Yeah, so again, within this, each of these equation, MAD and MSE, n is the number of observations. We already know these are like, yeah, given. So 11 to 20 are 10 number of observations. So n is known. The actual units sold. So these are your actual units sold, and we have to come up with forecasted units sold, which are unknown so far. Yeah. And once that's done, we have to do a subtraction between actual minus forecast, so which is given over here. So let's do the using linear equation. Let's get the forecast. Yeah. So again, as per this equation, equals to 124 plus 2 times t, which is 11. Yeah. So let me do that. So equals to 124 plus 2 times this value, enter, And again, like I said, I'm a fan of brackets. And this time we are solving all these straightforward equations. So yeah, again, it shouldn't be an issue. But again, whenever you deal with complicated ones, the bracket helps. So again, I'm just habituated, so I'll use those. So yeah, the first one is there. So as per this linear equation, the forecast for week number 11 is 146 and actually unit sold was 147. So by default, you know your A minus F will be actual minus forecast, which is 1 over here. We'll do it later, but yeah, coming back. So let's drag this formula all the way down and we'll get the values for all. Yeah, it's always a good habit to verify. So I'm just double checking everything. Yeah, A12 correct. Awesome. Yeah, so again, using Excel, you just made sure your first formula is correct, drag it all the way down and you got everything that was needed. So you got all the forecasted values using linear method. Now the next step is A minus F. So this is indirectly, this is my actual, which is A. And in this case, this is my forecast is, which is F. Well, I just use these short forms for now. So again, A minus F should be over here. So I'm doing equals to A minus F, enter. So 1, I drag this formula all the way down. So yeah, I got this A minus 1 for individual ones, and the next part I'm supposed to do is summation of all these, right? So I'm going to say equals to sum, close, select all these, close, enter. Yeah, so I got these summation. Oops, one more thing is, yeah, here there is a mod value. Yeah, so that's okay. I hurried, sorry for that. It's late in the night, so I was hurrying. Yeah. The next step is you are supposed to get this mod value, meaning doesn't matter whether it's positive or negative, you are only supposed to use positive value, meaning you have to convert it into absolute value. So for that, I added this ABS of this value. So equals to ABS, meaning absolute of this value over here, which is A minus F, close the bracket, enter, drag it all the way down. So we got this part. Now let's get a sum of it. So equals to sum of all these, close, enter. So yeah, I got this sum of mod of actual minus forecast 23, and my MAD value will be divided by n. And again, I know my data points over here are 10, so my n is 10. So by that logic, I will say my MAD equals to this divided by 10, enter. So 2.3 is my MAD for linear. So I'll fill out the information MAD. Oops, there is something wrong over here. Let's fix this orange color. Let's fix this. Okay, MAD for linear is 2.3. Yeah, or maybe let me just use this equals to this one. 2.3 is my MAD value. Yeah, for this. Same thing, let's get the MSE also, right? So we in this formula we need actual minus forecast, which we already got it, A minus F. Next step is we have to square those. Yeah, so equals to A minus F raised to 2, enter. Drag this formula all the way down, and again there is no mod or anything, so again we don't have to worry. So next time I'm going to do is equals to sum of all of these values, select all these, close, enter. I got 91, and it's sum, we got that summed and divided by n minus 1. So n minus 1 is number of observations minus 1. So my observations are 10 minus 1, so it will be 9. So my, oops, sorry, this is my, I'll just put it down, MAD, which is here. This is my MSE, which is above value. So my MSE equals to 91 divided by bracket 10 observations minus 1, enter. So 10.111 is my MSE value. Let's keep it a single decimal. So when these are important numbers that we calculated, let's keep it orange. Let's arrange it in a centered format. MAD is this, or maybe let me make it bold to highlight it. And I'll immediately fill out this information. So MSE using linear method is 10.1. So MSE using linear method equals to 10.1, enter. Yeah, so we got the first one. Both values using linear. Now let's do the same thing for new. And as per new, whatever your observation for the previous or whatever your sale actual value for actual sale in this case for a previous time period, which was 10, should be your immediate, like 11. In this case, it's not given. So I'm just going to say dash enter. In that case, yeah, so this is my actual and this is my if. I'll just also use this if, and again it's in yellow, so I know yellow is my neo and orange is my linear. So again, this is my f here. So again, technically a minus f we don't have. I'll leave this also dash blank. So absolute will be also blank. So the entire top row will be blank in this case. Then the next part, yeah. So as per new method, my forecast for time period 12 will be my actual units sold in time period yeah 11. So here it will be, so equals to 147, yeah, period. And as per that logic, I'll drag this all the way down. So these are the numbers I got for the forecast using new method. So awesome, this step also completed. Now yeah, we are trying to calculate the same MAD and MAC for each for this new method also. So the very first step is a minus f, which will give us this. So let's do that, yeah. So again, in this case, our f is this value, not this. So coming back, equals to a, which is actual 148 minus forecast using new method, which is 147, enter. I'll drag the formula all the way down. Just make sure everything is right. Yeah, this is looking right. This is, yeah, looking right. So awesome. So we did a minus f. Then we are supposed to get the absolute value of that, yeah, modulus or absolute. So equals to abs of a minus f, which is this value, close the bracket, enter, and drag the formula all the way down. So yeah, this is my abs, yeah, absolute of a minus f, a new method. Then I'll get the sum of it, yeah, equals to sum of all these numbers, closed, enter. And yeah, maybe I'll just, yeah, let's copy and I'll change the color, Control C, Control V. Let's use standard yellow color differentiation so we know what we are calculating, and the MAD value equals to this divided by n minus 1. In this case, the total observations I have is not like 10, unlike here. So these are, yeah, if I select all these observations are 9, and here it says 9 minus 1, right, n minus 1. So here equals to sum of all the absolute values divided by 9 minus 1. Yeah, n minus 1, enter. So it's 4.5. Yeah, so we got yeah, we got our MAD value. Let's make this bolder. So again, my MAD using new method is equals to this value 4.5. So again, quickly looking at that, the one MAD value with linear is smaller, right? So at least that one part is we got a comparative analysis, a clarity that this is smaller. Let's do the same thing for MSE. Yeah. So again, whatever we did here, a minus f, square it out, equals to this raised to 2, enter. Drag it all the way down here. Just double check. Yeah, looks like the formula is correct. Yeah, everything is good. So everything is correct. Awesome. Let's get the sum of it, equals to sum of all of these. And now let's do the division. Same. N minus 1. Oops, hey guys, I did one mistake. So for MAD formula, it is not n minus 1, but it's n. And this is correct. So this is supposed to be 9. Yeah, my apologies, guys. I'm taking it back. So yeah, sum divided by 9. So this is 4. So this is 4. Again, yeah, there is a difference. Although still its MAD linear is smaller. But yeah, that's a change. So that's my MAD formula. Now I'm looking at MSE formula, which is n minus 1. So we got the sum, top part, top of the square part, and now divided by n minus 1 equals to 202 divided by bracket 9 minus 1, close, enter. 25.25 is what I'm getting. So equals to this value, enter. Yeah, so if I do a quick comparison between these two, the MAD for linear is smaller. Yeah, let's bold it out and maybe I'll convert into green color. And if I compare the MSE between naive and linear, my MSE for linear is smaller, which is 10.1, just comparison. So looks like for both MAD and linear, yeah, MAD and MSE, the linear method gives me least of these two values. So technically, linear method is my most preferred method based on this information that we have collected, yeah, or we have solved this problem. So with that, yeah, even this problem is solved. Let's go to the next problem. It says linear regression and correlation coefficient. Yeah, so let's read it out. A manager of a seafood restaurant was asked to establish a pricing policy on lobster dinners. Experimenting with prices produced the following data. Yeah, so let's read, understand what the table is. First one is average number of sold. Yeah, average number of lobster dinners sold per day. That is Y, and price. Yeah, so again Y looks like it's a outcome and price is the input going on. And yeah, so 200, 190 again, yeah, so it drops from 200 to 160 and 155 to 133. And X, usually that's a representation, X is your input, looks like that's the case over here. So again, he is experimenting with prices. So he started with $6 and the lobster dinner sold were 200, and he started increasing prices $6 to $8, and looks like the dinner sold were 160. He further continued 8.25 to 9.25, and again this continued 133. So awesome, this is good information given. Questions asked is write a linear regression equation and determine the correlation coefficient and interpret it. Yeah, so let's go to our Excel sheet and go to problem number 8. Yeah, so again I have copy pasted everything in an Excel format over here. So yeah, these are the number of dinners sold, lobster dinners sold, and this is the price he was experimenting with. So yeah, like the prices are increasing, and looks like, yeah, but again this is just our interpretation. Let's do an actual analysis. So yeah, all I'm going to do is to solve the first problem, linear equation, and what is the equation is what they are asking. So I'm going to select all the data from cell A2 until cell B13, go to insert, go over here, yeah, oops, it has taken both as, okay, I know what happened, no problem. Yeah, let's give it a title. So unlike the previous time series ones, this isn't a time series, and yeah, so let's fix that. Yeah, again a good practice. Here we are, Y is our dinners, lobster dinners versus ERIC. Yeah, again, I'm a fan of adding X and Y also. For me, X is an input and Y is your output, and looks like in this case that's the actual case. So let's keep it that way. I'm going to make it bold. I think this is good enough. So let's fix this. I'm going to right click, say select data. So yeah, so I'm assuming this is your yeah, the Y. Awesome, that's true, that's my Y. And I'll remove this and go over here, and in my X I'm going to, oops, in my X I'm going to edit and going to select these as my X values. I'm going to say this way. Awesome, yeah, so this is correct. So these are my prices, $6 to 9.25, and these are my number of dinners sold. So yeah, this is looking correct to me. And since we only have one, we can, yeah, just give a header, say dinners. Since I'm actually seeing it as Y, let's name this also as, oops, no, I think that's good, less price X value. So yeah, write a linear regression equation. So again, I'm going to select this and add a trend line. So this is my linear trend line created by Excel, linear by default. So I'm supposed to display the equation. I want to select this, and just to make it yeah, for your better visibility, let's make it 20. So this is my linear equation. So yeah, I'm supposed to write this, or yeah, this is your one of their answer. Then B says determine the correlation coefficient and interpret it. So for that reason, I'm going to select this again and go here and say display R squared value on chart. So I'm going to select that, and as soon as I do, yeah, I can see that R squared appears over here, and it says that it's 0.9762. So again, the inference, let's actually type this in. So linear equation for y equals to, say, well, you can write it as this, or maybe, yeah, let me do this. 202.3 minus 5.7133x. So that's my equation. Yeah, so that's your first answer. Second one, equation answer is the, and like as per the theory, r square closer to 1 you have high level of confidence, and close to 0 you have least level of confidence. Yeah, so in this case it's very close to 1, so I will strongly say that r squared equals to, or I will just make a comment, r squared is close to 1.0. I can strongly infer that, strongly, I can strongly infer that there is a strong CORRE relation between the sale price, yeah, between the sale price of dinner, LOBSTERDINNER, and number of dinners sold per day. And since there is the, that negative part over here, that tells me there is a strong, like, a negative correlation. So I'm sure if you go with R for this, it will be a negative R. But yeah, as per this question, this inference should be more than sufficient for you all. So I'll just highlight this in this way. Yeah. So yeah, we solved the problem number 8 as well. Now let's go to our last problem, problem number 9. Here, let's read and understand. Again, this related to linear regression and correlation coefficient also. So this company, Lovely Lawns Inc., intends to use sales of lawn fertilizer to predict lawn mower sales. The store manager estimates a probable 6 weeks lag between fertilizer sales and mower sales. So again, this is my fertilizer, so 6 week lag. The pertinent data are, again, time period 1 to 7, 8 to 14 are given, so 14 weeks of or is it week? Yes, 6 weeks. Okay, so it looks like it's weeks of data is given, 14 weeks, and then fertilizer sales in turns 1.6, 1.3, and so on is given, and number of more sold, and they are saying there is a 6 week lag, and yeah, looks like this is for 1 week, so sold. So technically, if there is a 6 week lag, and again, let's see the lag whether it is this way or this way. So the store manager estimates the probably 6 week lag between fertilizer sales and mower sales. Okay. So once the fertilizer is sold, 6 weeks later, they must start seeing an effect on mower sale. Yeah. So week 1 is here, 1.6 ton, and you should see on the 6th week, or maybe say week 1 plus 6. So let's say 7th week. Yeah. So maybe this is correlated. So 1 over here, week 2 is period 8, week 3 is period 9, and so on. So okay, we'll work on those numbers in our Excel sheet. The question asked, it says write a linear regression equation for these, and then determine the correlation between two variables. Yeah, between the two variables. Yeah, again the same r square. Does it appear that a relationship exists between these variables, will yield good predictions or not? Awesome. So let's go to our Excel and solve this problem. Problem number 9. So again, this is the same thing. I copied everything in Excel. So this is time period. So again, we can plot it based on time series. But again, I don't think that's what they are looking for. They are looking for correlation, right, between X and Y. So effect of fertilizer sale on mower sold. Yeah. So again, 1 week and here. So you will start seeing effect. And technically, week number 1, effect will be seen on week number 7. Awesome. So we have to when we select this data again. Let me say Control C, add this one, paste this one, and add one more. Yeah, and again, this is something extra I'm doing, and technically I prefer doing it while formulating all the conditions that given. Yeah, so again 6 weeks lag, and this is the raw data given. That includes 6 week lag, but again for the first 6 week maybe there is no correlation, and then after 6 week, meaning here over here is something we should be seeing. So if I say 6 week lag, so I will rename this as without lag. Yeah, I'll just say without lag, and week number 7, right? So this week, so if I say this is my without lag, that is, week first through 6, there shouldn't be any correlation, and this will be with 6 week lag, right? Again with 6 weeks lag, and if I take this off, yeah, again I'm separating it out. So technically if I want to map these numbers over here, so again we have two different sets of data. One is without lag, one is with lag, and yeah, let me cut this all, because technically this should have an effect on the fertilizers sold in this week over here. So I'm going to say Control X and Control V, and yeah, I think I'll just keep it as this. So the very first, I'm going to write a linear equation for this. So for overall, let's select both of these and insert. Yeah, looks like it took as a time series. Let's fix it out. Select the data, edit, set of data. Okay, this is the one. I will take it off. Okay, got it. So remove this. So series edit. Let's see what this is. This is my Y, so that's correct. Okay, and this is supposed to be my X. I'm going to select all these and say X. Okay. So these are my fertilizer source. So let's fix the title. Say fertilizer versus lawn mower sold. Yeah. Yeah. So this is my title. So this is based on as is data. The last part includes the effect after 6 weeks. This is all the data. Yeah. So yeah, let's keep it aside. Now the next part. Yeah, this is without lag, which is the same thing. And this should be my with the lag here, right? And again, technically looking at this problem, looks like they are more interested in seeing the effect of fertilizer sale on sale. Yeah. So technically, yeah, we are trying to identify the correlation between this and this, this and this. Awesome. So I'm going to select all these cells B3 until B10. Hold Control on my keyboard. If you're using Apple Mac, use Command on your keyboard. Select all from E3 until E10. Go to Insert. Go over here. Go over here. Fix this. Let's see, fertilizer sales versus MO. Let's add this thing. Yeah, 6 week lag with 6 week lag. And technically this should be, let me name this as all data. Yeah. And frankly, this is what we should be looking at. So let's fix this. Right click over here, select the data, edit this part, go over here. This is my X, this should be my Y. So, okay, this gets eliminated. I'm going to select this, remove. And I'm going to go over here, select and, oops, yeah, select. I'm going to select all these. This is my X. Okay, okay. And this should be my Y. Yeah, that's my y. I'm going to say okay, okay, and okay. This is my series 2. And now let's draw a line. So select this, right click, add a trend line, add a trend line, display the equation. I'm going to make this bigger, make it say 20. Yeah, I think this is good. So this is my equation, and on top of it, let me add the correlation coefficient between the two. Does it appear to relation exist between the variables and give good predictions? Yeah, for that I'm going to select this. R square is 0.1321. So that tells me, yeah, there is no strong correlation between the fertilizer sold and mower sold. So yeah, these are my answers. So let's go ahead and write these. Write a linear regression equation. So this is my equation. Y equals to, I'll just say 7.5 plus 0.25 x is my linear equation. Maybe I'll highlight it with bolded. And answer is, does it appear to a relationship between? Yeah. So I'll say R S Q U A R E D R squared VALUE is close to, I will say 0, or you can write a 0. Therefore, I infer that there is no strong correlation between the fertilizer sales and mower sold. Yeah, so this should be your answer. I mean, I'll just highlight this in bold. So with that, we also solved our problem number 9. And let's revisit this problem number 6 that we missed out here. So again, this looks like it's very similar to problem number 7, where yeah, the data given data says an analyst must decide between two different forecasting techniques or weekly sales and roller blades. Linear equation name method. The linear equation is this. Oops, isn't it same as the previous one? Yeah, oh yeah, there is a little difference. So again, the FT is 127 plus 2.1 times T, and it was developed using the data from time of 1 to 10. Based on the data for periods, Eland's rule shown in the data, which of those two methods generate greater accuracy where if MAD and MSE are used. Yeah. So again, I will just like follow this whole methodology how we solve problem number 7 and solve this problem number 6. So with that, guys, thank you very much for your time and attention. We have solved all the problems as a part of this class, and hopefully you learn a lot out of this simple looking but very like important problems which you often come across on a daily basis or maybe at least a weekly basis at your like work, whichever industry you work for. Maybe your role might not directly require, or maybe it will require, and even if not, you must know how these forecasting happen so that maybe you can give some valuable inputs on a timely manner. So hope you learned a lot while doing all these assignments. Thank you very much for your attention. Thanks, guys.